Good morning students, a warm welcome to all of you to another session of mathematics. Today in this session we are going to discuss about the trigonometry chapter 11 of class 10th. Now, why have I taken trigonometry? As per the poll results which I had posted in the channel in the community tab, as per the poll results, as per your choice, I have chosen this. 62% voted for the trigonometry chapter, so I'll be dealing with trigonometry from today. Right, in the trigonometry today is the introductory part, the concepts we are going to learn, and where I'm always stressing that the introductory part and the concept part is very important for any chapter because it gives a strong foundation for you to solve the exercise problems. Now let's get quickly started with the chapter trigonometry. Now this is new for all of you, for 10th class students. This is a base in the 10th class. It will be useful for you in your higher studies, that is in your 11th and 12th, as well as in your intermediate also, and also in the further in engineering. So here in 10th class they have introduced this chapter. So this is a new branch of mathematics wherein this is a Greek word, derived from a Greek word. Now, tri means, you all know, 3. Tri means 3. And this gonia, actually it is gonia, that means it is sides and angles. What are the sides? Sides and angles of a triangle, right? Sides and angles. And metry is the measurement of, measure of. That means in totality, trigonometry is that branch of mathematics which deals with the measurements of 3 sides and angles. Now, that means it also deals with the relationship between the sides and angles in a triangle. Now, this is very, very important for us in our daily life. Now, if I want to measure a mountain nearby my house, a hill or a cliff, right? Now how do I measure? I just go on measuring with the measuring instruments. It can't work out. Now using this trigonometry, we can easily find, standing at some place, we can easily find the height of a mountain, the depth of a sea also, and also if you are flying a kite. Now the kite, where my kite is being raised, that also we can measure using the trigonometry. And many uses in engineering, physics and all, the trigonometry is working for us. And also if you see a slide in a park, now the slide, okay, the height of the slide or the slantness of the side, everything we can measure using trigonometry. Now let's start this. How to, we will proceed in this trigonometry. Now, first we have in our portion that trigonometric ratios. Now, what are these trigonometric ratios? We will know. Now, you were all well versed in the properties of triangles in your previous classes as well as in the same class, isn't it? The properties of triangles. Now, I have drawn a right angle triangle, right angle somewhere at B, suppose B. So this is A, this is C. ABC is my right angle triangle. It is right angled at B. Now, what are all these sides? We are well versed in the properties of triangles, isn't it? The properties of triangles, simple properties are sum of all the angles are equal in a triangle is equal to 180. And also the side opposite to the right angle is hypotenuse. Yes, this side is called as hypotenuse. Right, and these are the angles here. This is one angle C, this is one angle A. Now, these angles I can name anything, but they are only acute angles because we know that the sum of the triangle is equal to, sum of the angles in the triangle is equal to 180, wherein we have this is 90, so the rest two must be equal to 90 degrees. So they are acute angles. Now here I want to measure this angle or this angle using the trigonometry, where I told that trigonometry, gonia means the measure of the angles and the sides. So here trigonometry clearly gives us the relationship between the angles and the sides of a triangle. Now it's especially for a right angle triangle. Now here, if this is some theta, let me suppose, now we measure the angles with theta and all the Greek letters. Sometimes you can also measure with, this is called as phi, okay, phi. Not pi, this is pi. Pi value you know, isn't it? This is pi, this is 5. Phi also I can measure. Let me suppose this as phi, okay? Angle, right? Also alpha, beta, you can measure with whatever you want. This is called as theta. These are all Greek letters we were using for the, now here for the angles I am using. Pi value is a standard value, you know that. This is phi. Phi also can be used as an angle. So these phi and theta are the acute angles. Now we will know what are all these sides. Let us know the sides. Now if I consider, I want a relation between this angle and the sides. Now I am considering only theta. I am not taking this 5. Okay, theta. Now if I consider theta, for this theta, this side AB will be opposite side, isn't it? This side is opposite side, okay? See, just opposite to the theta. Now here this side BC for theta angle, it is called as the adjacent side. Just beside it, it is. So it is called adjacent side. Okay. So we should know the names of these sides. Now I am considering corresponding to theta, AB is the opposite side and BC is the adjacent side. Whereas the hypotenuse is one and the same. It is always the side opposite to the right angle. So these. Now if I consider phi, see here phi. Phi means the angle A. Okay, this phi. From here if I consider phi, for phi, BC will become the opposite side, isn't it? I want to measure this angle. So for this angle phi, BC will be the opposite side because it is opposite to it, whereas AB will become the adjacent side. So you got that point, clear? Now for phi, AB is the adjacent and BC is the opposite side, whereas the hypotenuse is one and same. Now we know all these sides, right? Now let's start with the trigonometry ratios. The word ratio itself tells something by something, isn't it? A division, right? So, but here we are following the trigonometric ratios. Now, the trigonometric ratios are, first one here is called as sine theta. Okay. Okay, let me take from here sine C. Okay. Now the angle is C there. Okay, sine C. But whereas this sine, the full form I wrote SINE is the full form of sine theta. This is one of the trigonometric ratio. I'll be explaining you. That means this is called as, when I am telling this sine as my C angle is theta. So sine theta. In short, we call it as, in short, not an abbreviation but in short. SINE, in short we write it as SIN, but we call it as sine theta. Okay, sine theta. Now, what is this ratio? What does it tell us? This is the first trigonometric ratio, and sine theta is equal to the opposite side by the hypotenuse. It is a ratio which is equal to the opposite side. So, I am writing in short, opposite side. Now, opposite side to theta. Now, here this is opposite side. For phi, this is the opposite side, isn't it? So, I have to mention it. Opposite side to theta by hypotenuse. This is the formula for sine theta. Sine theta is a ratio, trigonometric ratio, which is opposite side divided by the hypotenuse. Now, here, this is the first trigonometric ratio. Now, the second trigonometric ratio is called as cosine theta. COSINE, cosine C. Now I am measuring from C. So that is nothing but, in short we call it as, now angle C is theta. So in short, COS, cos theta. In short form we call it as cos theta. Whereas this trigonometric ratio is equal to the adjacent side by the hypotenuse. Adjacent side to theta. Now adjacent to which angle? To theta. Adjacent to theta by the hypotenuse. This is the trigonometric ratio called as cos theta. Right. Now here the third one is tangent C. Tangent C, that is, now C angle is nothing but theta, isn't it? Tangent theta. In short, the tangent we call it as tan theta. Whereas this ratio is equal to, tan theta is a ratio which is equal to opposite side by the adjacent side. Opposite side to theta by adjacent side to theta. Okay. So these three are very, very important trigonometric ratios. Now here, if I suppose for you to explain you, I will be giving you some values here. Let me suppose this adjacent side is 3 units. Okay. And this is 4 units and this is 5 units. Now 3, 4 and 5 form a, this is called as a Pythagorean triplet. This is 3, 4, 5. You are well versed with the Pythagoras theorem, which tells us the hypotenuse square is equal to the sum of the squares of their sides. So 3, 4, 5 forms a Pythagorean triplet. Okay. Now that means 3 square plus 4 square is equal to 5 square. So that is called as a Pythagorean triplet. So here that I have taken 3 units, 4 units and 5 units for you to explain the sin theta. Now here I have told sin theta is opposite by hypotenuse. Now opposite to theta is 4. Now here if you see here 4 by hypotenuse is 5 units. So simply sin theta here in this case is 4 by 5. Now let us calculate the cos theta. Cos theta is adjacent side to theta by hypotenuse. Adjacent side I have taken it as 3, whereas hypotenuse is 5. Now if you take this, tan theta is opposite side to theta, that is this 4 by adjacent side is 4 by 3. Okay, these three are the trigonometric ratios. Now here in tan theta we can also deduce that this tan theta can also be taken as here sin theta by cos theta. How? I'll explain you. Tan theta is equal to sin by cos. Now sin theta we know that opposite side by hypotenuse, isn't it? Now here let me erase this Pythagorean triplet. Here now cos theta is adjacent to theta, adjacent side by hypotenuse we know by the formula. Okay, so both the denominators get cancelled, we get only opposite by adjacent. That's what opposite is 4 here and adjacent is 3, 4 by 3 we got. So we can tell that tan theta is equal to sin by cos. This is another formula we got from those two. Okay, that means here when the sides are not given we can also calculate tan. When sin is given and cos is given, we can easily calculate tan, that is sin by cos. Tan theta we can easily find out. Now here these three are the trigonometric ratios and we have 6 trigonometric ratios which are the multiplicative inverse, or we can also say that they are the reciprocals of these three. If you are perfect in these three, you can find the other 3 easily. Okay, now here let me tell you the fourth one. The fourth trigonometric ratio is cotangent theta. Now here we are telling C. So cotangent C is equal to cotangent theta. Okay, the angle is theta here, and in short we call it as cot, COT, cot theta. Now this is equal to, I have told that all the trigonometric ratios, they are multiplicative inverse. Multiplicative inverse, in simple words we can tell it as the reciprocal. Okay, now the reciprocal of tangent, tan theta is cot, I am telling. So tan theta means here, I can tell this as reciprocal means 1 by tan, right? Now tan theta, I know that opposite by adjacent. So what will be the cot theta? It is just the reciprocal. That means adjacent side to theta by opposite side to theta. Okay, adjacent by opposite. So here we can say that cot theta is 1 by tan theta. Multiplicative inverse of tan theta is cot theta, and multiplicative inverse of cot theta is tan theta. Vice versa, right? So they are the reciprocal simply. Now here, so I got, if I remember only 3, I'll be getting all the 3. See, this is the reciprocal of this. Now see, let's take the other one here. Now if you say, if I take secant theta, the fifth trigonometric ratio is secant theta. Now secant C. Okay, we are going like this. So that is secant theta. So in short we call it as sec theta. Okay, sec theta. This is a multiplicative inverse of the cos theta. Okay, remember S and C. Likewise, you have to correlate, right? Secant is the multiplicative inverse or the reciprocal of cos theta. Now what is cos theta? Now I told this is reciprocal of cos theta. Now what is cos theta? Cos theta is as adjacent to hypotenuse. So it reciprocal means what should I write? Hypotenuse by adjacent side. Okay, hypotenuse by the adjacent side to theta. Simply just the reciprocal. Now the last one is here cosecant C, that is equal to cosecant theta. So in short we call it as cosec theta, COSEC, cosec theta. That this is the reciprocal of our sin theta. Okay, so 1 by sin theta, or we can also write here, if you interchange it, sin theta is equal to 1 by 1 by cosecant, sorry, cosecant is equal to 1 by sin, sin is equal to 1 by cosecant. You can interchange these two, isn't it? The likewise here also, 1 by secant is equal to cos, 1 by cos is equal to secant, 1 by cot is equal to tan, 1 by tan is equal to cot. That means vice versa, they are the reciprocals to each other. Now what is sin theta? Sin theta is opposite by hypotenuse. So the reverse we have to write. So the hypotenuse by the opposite side to theta. Opposite side to theta. So likewise this is the reciprocal of sin theta. So now here I am telling you to remember these 3. So whereas sin, cos and tan, so that you can easily form the other 3, that is cot, secant and cosecant, by just reciprocating them. They are the multiplicative inverse of these. So all these 6 form the trigonometric ratios. With the help of these trigonometric ratios, we are going to solve many problems. If any side is not given, the relation between the angles and the sides. Now in triangle we have 3 angles and 3 sides, isn't it? All the 6 elements. So the relation between all the 6 elements we can easily find out using the trigonometric ratios. Now here I'll also give you the values for this. Now for this triangle, now we'll also calculate the cot, isn't it? Okay. Let me also calculate the cot value. Here I'll write. There's no space there. So the cot is 1 by tan. So adjacent to theta by opposite to theta. See here, adjacent is 3, opposite is 4. So this comes to 3 by 4. So just reciprocal of tan, isn't it? 3 by 4. You can check it out. Here, if you take this is secant. Secant is a reciprocal of cos. Now, what's the value of cos? You can also write 5 by 3. Or can go by hypotenuse by adjacent. Hypotenuse is 5, by adjacent is 3. 5 by 3, clearly. Now, the last one is cosecant theta. Okay, cosecant is a reciprocal of sine. So, that means 5 by 4. You can also check it out. Hypotenuse by opposite side. So, hypotenuse by opposite side. 5 by 4. So, the values we can find out. Here, today, with this trigonometric ratios, we can students, I want you to be perfect in the trigonometric ratios. They are the base for all the calculations. Now, if you are perfect with this concept, then we will be looking over to the exercise problems and further. Okay. With this, I'll end the session today. In tomorrow's session, we will be doing the exercise problems. Thank you all.